Today we will solve the problem 7.3 of Griffith 4th edition Introduction to Electrodynamics. The problem 7.3 is consists of two parts. Now we will see part A. Two metal objects are embedded in weakly conducting material of conductivity sigma as shown in figure. We have taken two metal objects, one and two, in a random shape, and we have embedded it in a material which is having conductivity of sigma, so that the resistance between them is related to the capacitance of arrangement by R is equal to epsilon naught over sigma c. That is, this resistance is related to capacitance. We have to prove it. Now you take by definition I is equal to integral j dot dA. Here you know this j by definition is equal to sigma E. Uh, so where sigma is conductivity is a constant we are taking out, then it will become E dot dA. We know very well it is integral. Integral E dot VA is integral E dot dA is nothing but our Coulomb's law, which is equal to Q pi epsilon naught. So I have replaced with this integral by Q over epsilon naught. Then you know this Q. What is Q? By definition, it is equal to CV. I am replacing Q by CV. So that is I is equal to sigma CV over epsilon naught. Uh, then what is V? V is equal to IR. V equal to IR. So I am replacing V by IR. Now you bring the I to the left hand side. I divided by I is 1. So remaining term is here sigma CR over epsilon naught. Then R is equal to epsilon naught. You bring this epsilon naught to the other side except R and sigma C to the denominator. So we have proved R is equal to epsilon naught over sigma C. That is, the resistance is related to capacitance. Now we will move on to the next part. Now the part B is, suppose you connected a battery between 1 and 2 and charged them up to a potential difference of V naught. If you then disconnect the battery, the charge will gradually leak up, so that V of t is equal to V naught e power minus t over tau. Here tau is the time constant. So, and find the time constant tau in terms of epsilon naught and sigma. Now you take V is equal to by definition Q by C. With respect to resistance, it is equal to I into R. Now we are finding the leakage. That is, current will decrease. So I have used negative sign and bring this R to the left hand side. So this will become minus I is equal to Q over RC, because I have brought R here. Now you differentiate. Basically, I is nothing but the rate of change of charge. That is dq by dt. I am bringing this negative sign to the other side. Then if you integrate this, you will get Q is equal to Q naught e power minus t over RC. Q naught at initially when t equal to 0, we have seen already that Q of 0 is equal to CV naught. Q is equal to CV. So since at the time we are calculating, it will become CV naught. We have seen this in earlier problem also. Then I of t is equal to 1 over RC. This 1 over RC, uh, because I is equal to Q by RC. So 1 over RC Q. This Q is C V naught e power minus t over RC. This RC we are taking as a time constant. So I am replacing that RC by tau, and here you can see this T C and C will get cancelled here. So naturally I'll get V over R. Here this will become V over R into this exponential term e power minus t tau. Now, if you bring R to the other side, R into I, what is R into I? Is nothing but voltage. So this will become V of t, V naught. This V naught is here. I of course we are R brought to the left side. V naught e power minus t over tau. Now we have to prove tau in terms of epsilon naught and sigma. Now in section A, we have seen R is equal to epsilon naught over sigma c. So if you bring the c's to the left hand side, it will become RC is equal to epsilon naught over sigma. RC is nothing but tau. I am replacing RC by tau. So tau is related to epsilon naught and sigma by this relation. That is, tau is equal to epsilon naught over sigma. So thank you very much for watching my video continuously and supporting me. Thank you very much.